I doubt anyone is watching it right now. We'll post it. We'll start covering the material for today. Today, we're going to do another quick review. We're going to do hashes and reading and writing files real fast. Then we're going to talk about method parameters, some new options that we haven't gone through on what we can do for method parameters. That includes default values for parameters, symbol parameters, and splat parameters. Not critical to us right now, but it's useful to think about some of this stuff. We're going to quickly review objects, and then we're going to start introducing the concept of classes. We will dig into classes a lot more next class, and that'll be what we'll probably be spending a lot of the rest of this next, I think we have 3 weeks left counting today. So 3 weeks of classes. We'll probably be going over classes and building on top of that. And the last week will be most likely introducing more of the larger Ruby ecosystem beyond just writing your code from scratch. We'll pull in libraries and other functionality externally. So quick review, hashes. A hash is just an object that uses keys mapped to values to store other objects. It's like an array, except an array uses indexes mapped to values to store other objects. A hash uses keys mapped to values. Hash is written as hash equals, and then curly braces, or hash equals hash.new. Both of those are creating a new instance of a hash object. And then you can work with those. Objects are stored and read from a hash using array-like syntax. So we've created a new empty hash, and now we've added a key of 42 with the value of the answer. And then if we wanted to read that out, we use that same array-like syntax, hash of 42, and that gets us the output. People feel relatively comfortable with hashes at this point, so we think it'd be useful to have more homework to go over them again, or feeling good? All right, hashes are a very commonly used concept in Ruby. You'll see them all over the place, so it's definitely an object type you want to get comfortable with and just understand how to use them. We also talk about working with files. You open a file with open and then the file name. It's useful if you assign that to a variable so that you have access to it later. You can read the content of a file just using file.read. Again, save it. There's a lot of other methods where you can read in bit by bit of the file. For example, you can read line by line and different approaches like that. I encourage you to go check out the file documentation in Ruby. What happens when you get, it's not called a file, it's called an IO object usually, once you've actually opened it and have access to it. And that's so that Ruby can treat a lot of different ways of getting input similarly. So once you've gotten it, it's called, I believe it's called an IO object in their documentation, but I encourage you to look at the different options and methods that exist to pull content off of that. We also learned how to write files, and that you open it, but you add this second parameter of W for writing it. That's going to overwrite. You could also change that to a few different options, like I think the W plus instead, appended. And then you just use puts on the file, which is this IO object handle that you have now, to write into it. Make sure whenever you're working with a file, when you're done with it, you close it so that it all gets written out at that point in time. Something new that we haven't talked about before is working with YAML files. YAML it's nothing particularly special. It stands for yet another markup language, and it's just a short way of writing some information that doesn't have a lot of complex syntax around it. So if anyone's ever looked at an HTML file or an XML file, for example, there's a lot of structure around it that sort of obscures the content that you care about. YAML is an attempt to have something very flat so you can see your content without having a lot of that structure built into it. So Ruby, a lot of Ruby utilities and tools really like to work with YAML files as well because of that flat, simple to read approach. Just like Ruby as a language is very easy to read compared to a lot of other languages. So Ruby has some capabilities built pretty low level into it to allow you to work with YAML files. And the way you can do that is if you want to load a YAML file, you can require quote YAML. We'll talk more about what this is doing in the future, but this is pulling in, I don't know what the term is in Ruby land. What is it called? Is it a library?
It could be a library. I mean, it is a library. You're thinking of gems too, but YAML is not really a gem.
Yeah.
So it is a library.
It's a library. So it's pulling in a library into your Ruby code that gives you access to more functionality. This is, we'll really dig into this a lot more near the end of class, but this is how pulling in other people's code that already does things that you're going to want to be able to do. This is a very, very powerful tool in order for you to build code much more quickly. So far, we've built everything from scratch, piece by piece, just using more or less the Ruby basics. This is a very, very common pattern when you're doing more complex programming because you're not going to write everything from scratch. You're going to use huge libraries that other people have written to do massive things. So this is a good example of it. Here we're just requiring this YAML library, and then we're creating a hash off of it this way. So when you require the YAML library, it adds this YAML class, I believe, into your code where you can call .load. So if we break this down, we've already seen file read or open above. This is a shorthand to do it all in one step. This could have been written a little differently if we wanted, the same way we had it before where we did a file read, we have our value, and then we pipe it in here. This is just a very shorthand to do it all at once. Open it, read it, close it, get everything out of it. So it's getting all the data, and then it's passing that into this YAML.load method. YAML.load method knows how to read YAML files and how to convert them typically into hashes, as it's doing in this case. So it just looks at this, and if you were to look at this, this looks a little bit like a hash. We've got what could be a key and a value, and so that's what's going on with this bit of code is the YAML library is pulling in that file, reading them in as keys values. You can also, and this is really handy, convert a hash to YAML if you want to output it in a nice readable format in a file. So if you remember, again, we learned how to write files up above. So if you convert to YAML and you write that out to a file, then you're gonna have a nice writable or readable file that you've been able to write out. So let's build on this. As a class, let's go ahead and work through an example of some of this file access. I'll use this scope one again because I want to keep around the other code in case I need it. I hate how it keeps jumping back up. What we're going to do is we're going to write a program that takes inputs like name and age. Name, age, name, age, name, age. We already did something similar to that in our last class, so I'll probably go back and just steal that code because I'm lazy. The program should save the info into a file. Say ages.yml. YML is typical file extension name for YAML. And then when the program runs, it should load this file and allow saving more things into it if we want to. So this is a way to continue to extend. So let's try and work through this together. We've got a little bit of code that we already have right up here, which lets us get a file and read it in. So let's just steal that, but we don't want our file to be data. We wanted it to be what? Pages. All right. Sounds good. Again, being a properly lazy programmer and knowing that I've already written this code or something close to it. I'm going to hop over here. and steal my existing code. I'm going to want that search capability too, so let's add it in. Let me add one more here so we can get out of here. If we enter an empty string. All right, so far, we've just been building on a little bit of what we already have. Here was the example that we had in our code just now, reading in this ages.yml. And then I pulled these methods over from our other program, and we've got the loop that we had before of being able to add people or search for somebody. So we're not doing anything yet with what we've loaded up in here. Does anybody have any suggestions on how we can combine this bit of code that's pulling in our YAML content with the code that we had previously for our persons hash or people hash? Let's try this. Let's see if this works. So let's make this people right up here. So that we're creating it. I don't know if this is going to work right now, or if I'm going to have something else that I need to do. Let's see what we have. Okay, it blew up, and blew up because my ages.yml file doesn't exist. Well, I'm going to be lazy, and instead of properly dealing with whether it exists or not yet, let's just create one. Even though it doesn't really have anything in it. So let's try it again. Cool. So let's add somebody. Oof. Oh, can anyone tell why we blew up? I had a typo here. Try that, okay. Add person, undefined method. So it doesn't like this right now. What do I have wrong? Def, add person. Def.
Do you need a hash string?
Saying that people is false or something.
Oh, it's saying people is false. I see what you're saying. Let's try this. I'm gonna not do this right now for a split second. All right. Seemed like it worked. Fine, I'll change you. Let's make it explicit. Didn't like that. All right, let's try it one more time. Okay, why am I not exiting? Oh, because I'm not doing anything there. See? The perils of live coding. All right. Okay, so right now it looked like we had a problem with this YAML load. I'm not going to. What? I think it's because it's empty. And so it's not, the YAML code can't figure out what to do with it and what type of object to create.
Yeah.
So.
Can you take the hash, you know the hash, right? Can you do hash to YAML and make the new file?
I could do, there's probably, and I just haven't checked, there's probably a method right on the YAML bit that will let me say to hash or something like that when I create it.
Or you can turn the hash.
But again, I'm being lazy. I bet this will work. Fix my problem. I'm just sort of front loading my file a little bit. So let's see now. All right, so now we're working. But we do have a couple things we're missing right now. A, we're reading it, but what we want to be able to do is read it and then write back out to it when we're done with anything that we've added into our hash. So how do we write to a file? What's that? With the writing logic. Yeah, it's with the writing.
Writing object.
Oh, okay. So we did, you remember? File equals, what's that? We need to open it, right? I want to open pages.yaml, right? And how do we make sure we can write? That's in a W. We're going to want to do this. The reason I'm putting it down here is we want to only write it out when we're done with the program. So, okay, we finished running through this. Now let's, if we're exiting, let's put this stuff back into our file. And we just learned how to convert a hash to YAML, right? So now if we want to, let's go back here and review what we had. File.puts is how we can write into a file, and hash.toYAML is how we can get YAML out. So any idea on how we can write what we have from our hash into our file now? Name and age. Yeah, we want to grab everything that we have in our people hash and put it in the file. Right? Nope. What? Yeah, there might be a problem with this. I don't know. I can think of some things that may be issues, but let's see. All right, Ruby scope. We know we can search what we already have. Let's add somebody else. Add somebody else. All right, so we should be able to search, right? Cool. That didn't work. It's fine. And then we want to quit and exit out. Now let's check and see what we have here. Sweet. I don't know what this is, but whatever.
The lines.
Yeah.
I think it's turning it into a rank now.
So let's see what happens when I read it in now. And let's search. I think it's some sort of indication of what type of object it is for YAML.
Okay.
Probably. YAML is just adding something to it. That's awesome. We've basically created a very, very primitive database with this now, right? Because we can, it'll write out every time we add something new to it into this file when we exit the program. And every time we open the program, it'll read the content of it and allow us to use that in the program. Does that make sense? Any confusion on that? All right.
So I guess essentially the program is updating people, right? And as it updates people, then you can just put that to YAML onto the file at the end.
Yeah, well, so what we actually did, since we open it with the W, what the W will do is overwrite the file, but we don't need to append to it because we're putting our whole hash in it every time. We just want to use it to store it. So every time it'll rewrite all of the hash content onto it, not just the new entries. So if you wanted to make a much more advanced version, it would be much harder to write it where you only add the new hash entries into it. You could do it a few different ways. Like you could have them flagged as new so that you know to add these in when I'm done. File.puts, it's just put string into the file. It's the same as put string that we have normally, except this one is doing it off the file object instead of off of the standard in or standard out, which is what the other put string is. All right, so let's introduce a few new ways that you can pass parameters into methods. A few new options for us. We're used to passing in standard parameters, name, age, ordered parameters like that. We've done that a decent amount at this point in time. You can also, whenever you're declaring your method, you can declare what will be default values for parameters. So that means if I don't pass in a name parameter, two parameters here, if I only pass in, say, call my method with no parameters, then inside of it, name is going to be an empty string and age is going to be 0. But you can make those whatever you want. This could be, so if we're writing this out, let's go ahead and just create this. Let's give it something different. And it is not happy with me.
Yeah.
Oh, because I'm not an IRB. How about that? So if I call this now without passing anything in, it's going to blow up, right? Because I did something wrong.
Capital name. What's name?
Ah. Yep. Of course. So if I call it now without anything, it's going to use those default values. But if I pass in values, it's going to use whatever I passed in. And if I only pass in one, it's still going to use the default for the other arguments. Does that make sense? That's how that works. It's really useful when you have parameters that might be optional or they have a standard default and you only want to change it sometime. An example of that, we've already seen things that work like that. Can anybody think about one that we've just worked with just a moment ago that's very similar to that? What? We did open on files, right? And if we pass in just one parameter, then it just opens it to read, which means it's using a default value on the other parameter of this is a read version of it. But if we pass in that second parameter, it changes the way that it works. You have a question?
Yeah. So does this help validate your parameters? You have to pass a string for me. You have to pass an integer.
No.
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 This.
Yeah, this doesn't lock you into type at all with this still. So
What if you pass two integers?
if it's not,
Two integers, we'll still do two integers. 5 is 5.
So you can convert 5 to string.
No, I think it will stay the same. So we, yeah, integer. It will say integer is integer.
yeah.
Is
Oops.
there any way you can validate the
Why
parameters
aren't you gonna work now?
at all?
Like type static. I don't know if you can enforce types in Ruby.
The way you would do that, Ruby being a very dynamic language, you're not going to do that easily the way that you can in some other languages. And that's sort of intentional. But if you were trying to do something like that, what you would probably write is, and there would be other ways to do this more easily. There's stuff that makes this simpler, including in Ruby. But imagine in this my method, we've got the two arguments. We have name and age, and you want to make sure that they're what you're expecting for types. You could, as your first line, have something like if. Let me go ahead and, that was weird. Let me create a name at the top level. So this won't just error out. If name.class equals, and then you could, I don't know exactly how to get the class type off the top of my head to grab, I mean, if you're being, I'll be lazy here. Equals an empty string dot class.
So you can do like this capital string.
I think so, yeah. There we go. So I could do string. And so you could check and then spit out of your function if they aren't what you expected. Tell the user, hey, I only take integers for age. You're crazy.
So you actually have to method to check for.
You'd write your checking yourself. That's the most straightforward way to do it. There's going to be stuff that can wrap around it to make it easier if you're looking for that, but the most straightforward way is to check it directly inside of your method, what you're looking for. So the next thing we'll introduce for the new ways you can pass parameters into methods. We already have defaults and we've got this standard order, right? But what if The only thing that defines this, again, was the order. So you saw me just now call this. Wow, that code's weird. It's in like a half-run state. And I don't know. All right. So me call this with this, which is definitely backwards. But that might have just been, oh, shoot, I didn't know that name came first and age came second. I didn't quite understand the order of them. And so I called them with the wrong item in the wrong place. So one thing you can do is you can use keyword arguments or symbol arguments. The way it works is instead of just defining them with a straight up variable name, use a symbol in place of it. So name colon, age colon. So let's go ahead and rewrite this function that we just had, and we're going to use symbol-based arguments instead. And I'll even give us defaults like we had before. And I don't know what's going on with my, that was weird. What just happened? All right, we're gonna get out of here. Maybe I want to put an M after every B, I don't know why. But these are symbol-based arguments. You can still treat them the same way when you're inside your code. So inside of the method, you can call them with the variable name that you used for these symbol-based arguments. But what it allows you to do when you're calling it is I can call it with a different order. And because they're symbol-based arguments, instead of just being order-based, it will actually look at the symbol names that I passed in, age and name, and map those to the correct arguments in my method based off the names of those symbols that I used. So that allows you to pass your arguments in any order, because you're passing them in by the named symbol that you're using. You'll find this also used a lot. It's a very, very popular paradigm in Ruby because it allows for the flexibility of functions taking different arguments and you not having to specify all the arguments maybe in between. Because you can imagine if you had a function or a method that has, let's say, 6 arguments, and you really only care about the first and the 6th one, and everything else in between you don't care about. If you don't have some sort of way to reference just those arguments, you're gonna have to write it out and put something in for all those other values. Symbol-based arguments make that much easier, where you can pass in just the arguments that you need and let other ones default to whatever they needed to default to.
The other cool thing about it is the error messaging, right? So if the method doesn't have a default value, and then you just call the method without any parameters, it will tell you what you're missing. So, for example, if age did not have a default, and you just call my method, it will say, oh, you need to pass in age.
Right, so what you're saying is, I'm gonna be lazy here, rewrite it like this. Missing keywords, name and age. So that's really useful. It tells you have to have these. Yeah, there's a lot of powerful uses for keyword-based arguments. In fact, I would say that in most cases, it's probably a better approach to write keyword-based parameters for your methods than it is to just pass them in order. Maybe if you only have one or two and they're always there and always the same, by the time you get anywhere beyond that, keyword is definitely a preferred approach for a lot of different reasons. That make sense? Am I getting any head nods? I'm just getting blank stares. I'm scared. When do you go on versus like pause? Like I'm just getting blank stares. I don't know what to do. I don't know. I don't know what the answer to that is. It's the life of trying to be a teacher, right? You're constantly seeking validation. Please tell me something, anything.
Questions, please.
Questions? A question at least tells me you're listening. So the last type of argument we're going to, or way that you can pass in parameters, is splat. You won't encounter this quite as often, but it's really useful if something can take multiple arguments. A splat argument will take everything that has been designated with that splat argument and put it into an array, which means that you can collect more than one argument and have them all stored in an array. A very easy example of this might be add. So let's def add, and we'll splat. What are they even called? I don't remember my basic math. Numbers. Let's call them numbers. And we can do being smart. Now we wrote an add method that can take any number of arguments and return them instead of just one. Oh, thank you. Yeah, it's all wonky now because I think I just defined something weird and let it blow up. It's like, I don't know what you're doing, dude. You are crazy. So it's useful in cases like this. You won't see it all the time, but it can be very useful when you want to be able to pass in a variety of arguments all at once and do something with them, usually the same thing. But you won't encounter it quite as often. When you're writing these different types of arguments, it definitely, I don't actually think Ruby forces this, but definitely if you're ever going to write something like this, try and put your splat arguments at the end, or you're going to get some very strange, maybe unexpected behavior, because I think Ruby allows them in the middle, but it's going to be weird.
Yes, I mean it does.
It's going to be weird. I don't think, best practice, I would say don't. Let's see here. I think that's all I had for new ways of calling methods, new ways to pass in parameters. Any questions on that? No? All right, I got no's. That's good. I got something. Validation. So let's do a quick review of objects. Again, in Ruby, everything is an object. Everything you're working with is an object. Objects have methods and properties. That's pretty much the definition of an object. And then this is a different analogy than we've used before. I try and go with different ones so that maybe one person understands one analogy, somebody else understands a different one. If you wanted to try and map the concept of objects into language structure, you could think of objects as being like nouns. These are things. The methods that an object has, these are verbs, these are actions. This is reverse and find. These are actions that you take on it. Write. And in properties and attributes, these are adjectives that describe your object. It's 5 by 5, it's green, it's, Those are just descriptive concepts for it. Does that make sense? Objects again. Everything you're working with is an object. An array is an object. And then in Ruby and a lot of languages, objects are modeled with a class. So the way that you actually model what an object is going to be, how to create objects of a certain type, is with a class. There's, at least in my mind, there's no perfect real world analogy for a class, because there's not this perfect thing that creates an object like this marker that I used as an example before. But there are some things that get close to what a class is like. And some of those would be blueprints or close to a class. Blueprints are, you can imagine a blueprint for a house. That's a little bit like a class for that house, saying here's how to create it. Factories that manufacture items, that's close to a class. You might think of a car factory. That's like the Ford Explorer factory is a class for creating Ford Explorer objects. A cookie cutter, it's another type of example. That's a class that helps create this objects of a specific type. And it's molds for making things, not the fungus. Molds are another good example, a lot like a cookie cutter, just a more complex item. So anything that you have that's ever been plastic mold injected, like these are, that's sort of a class for how to make a portion of that. But they don't map perfectly to the concept of classes in programming languages. Programming language classes are more closely tied to the real objects that you're creating than any of these would be. These are their own, much more distinct objects. And these also don't, I guess, provide quite as much structure as a programming language class does. Yes?
Would it be like in game design, if I make a prefab, it's like the parent, and if I change the prefab, it changes all the children, all the objects made from that original. It's basically becomes like a template, and everything I can duplicate, make other objects out of it, and I can make changes to them that don't affect the parent object.
Yeah.
But if I make a change to the parent object, to the prefab, then it changes all the children.
Yeah, I think that's a good example. Or you were talking about templates. It made me think of anyone who's worked with templates in any PowerPoint or Word or anything like that. You can pull in a template that will give you a predefined structure. And, oh, this is what the slides in this template look like. And I think it was fantastic to say, I can change those individual slides in this presentation without changing my template. And I can change my template, and when I've changed my template, now every set of slides I create off of it will be created differently than they were before. I think that's another good analogy, and probably really close, probably closer than any of these, but again, it's not quite concrete in real world, but it's probably closer than any of these would be to the concept of what classes are in programming languages. So creating classes. A class is created using the class keyword. If we're creating a class, we create class thing, and now we have a new class that exists. And we already know how to create objects from a class. So how do we do that? Got new. All right. And we can check what class was used to create an object using the .class method on it. So now we can start creating our own classes at this point in time, creating classes that can do things to objects. But boy, that class is incredibly boring. There's nothing in it. It didn't add any functionality, so where's the value? So let's start adding a little bit. First thing is when you call new on the class, because the new is on the class, it'll call initialize after it creates your object. It will call initialize on your object that gets created. This is going to be, and we'll talk about this, this is what's known as an instance method. defined here. So we'll write this one out now. We'll make the thing a little more, we'll give it at least a little bit of functionality.
They initialize that people, so it runs with that too.
So what's going to happen, the workflow behind the scenes, when we create thing one this time, is it's going to call thing.new, and that's going to create a thing object. And then once that thing object has been created, it's going to call initialize on that thing object that was just created. And that's what's going to initialize your object with anything that you need to have initialized. We'll do a lot more with this, more complex initialization in the future. Right now, I'm just introducing this concept and creating a thing. We're just letting the user know, hey, you created it. Should probably say create it, because at this point in time, it does exist. It's just initializing the bits around it. Now you'll notice here, this def initialize, this is nested inside of the class expression. That's going to be the way that we create instance methods. You're going to create an instance method by creating the method inside of your class. So if we wanted to add another instance method, which we'll see in just a moment, we would just add another def and then our method name and the body of the method with wherever we want inside of the class. That means that every object that we create using that class is going to have access to those instance methods and can call them. Just like on if we had an array, you can do array.sort. That's an instance method on arrays. So every array has access to this sort once it's been created. And every other instance method that you create will be on those objects as well. You can check those explicitly by doing, probably going to get this wrong. I think it's instance methods. It's an instance method. Maybe you have to do it on the class. There we go. So if you go to the class itself, you can do instance methods, and you'll see here's all of the methods that are going to be on any instance of this class, any object created off of it. What's that? I don't know what all these are. What is? Where's lazy at in here? Is this alphabetical? Where's lazy at? Tell me when I'm near it. Right here. What's lazy? I have no idea. I could take a guess from knowing a lot about how programs work, but I could be very wrong. My guess is lazy allows for a very fancy array. An array that, yeah, okay. So lazy, you ask a complex question. A lazy array, I believe, and I'm going to look into this, but taking a shot in the dark, lazy would mean that you can do things, act like stuff exists on it, and it's not actually going to set those properties or add these items to the array or do certain things until a later point in time when it's required that it does that for something else. So it's an attempt to defer running the code that needs to run until it actually has to run, as weird as that sounds. Yeah.
Is it memoization then?
No, it's almost the opposite. Okay. You'll run into it a lot with, the place you run into something like that a lot is with database code, where you can write a lot of code that acts like you're maybe running queries against a database to get things out. but until you do dot call or something at the end, none of it actually ran. It was just, you can pass that around acting like you've actually done things with it. And until you make the actual call, it's not going to run any of it. But you're treating it like the object has all the properties that it should have at any point in time before that. It's a complex concept.
And it's called lazy.
And it's called lazy. Because a good programmer is a lazy programmer. And good code is lazy code. I don't want to do any computation I don't have to do. Okay, so we've talked about instance methods. Now let's add one other thing, instance variables. Instance variables, this is how you get properties on your objects, unique properties for them. Instance variables represent the state of the object, and they're unique to each instance of the object. One thing that I maybe glossed over a little bit on instance methods is instance methods are defined in the class, and they're actually shared on every object of that class type. So each object you create doesn't get its own copy of that instance method. It just calls down into that one copy of that instance method and uses it. However, instance variables are unique to each instance of an object. These ones are not going to be the same. And you create instance variable using an @ symbol inside of your object. So we'll go ahead and make this thing a little more complex than it was. And if we do thing2 equals thing.new, we can look at it and see, all right, we have thing, object, fine. But what we did in our code over here, in our initialize, was we created a couple instance variables, @question, @answer. So we've added a couple variables that are going to be unique to each instance of this object. So let's go ahead and do thing2.joke. If programmer says change the light bulb, none. It's a hardware problem. Oh, it's awful. No, it doesn't deserve it. But let's do this. Let's create another one, and let's change. I don't know if I can do this. Can I do this without setters and getters?
No.
Yeah. What a shame. I need to write a setter and getter for it.
You can pass in a parameter to initialize and override. You know what I'm saying?
Yeah. Yeah, I do. Do I see? I didn't review my syntax ahead of time. You want to help me out on passing in those parameters correctly?
Yeah, it's just after initialize. So,
Just add them on it. Just a moment.
So just copy it, right?
Yeah, just like this.
Yeah.
And you can see what I'm doing here is giving it a default without having it hard-coded in there. The same way. So if you look at this initialize now, we'll step over and look at the code. I changed it a little bit. And it's taking in 2 parameters. It's taking in question and answer. And then it's going to assign those to instance variables inside of it. So let me steal this code, bring it over here. All right. Let's try this again. All right. But now we want a different joke. I'm gonna pass them in here, right?
Yeah.
So, what's a good joke? Anyone have a good joke? No good joke? Oh, that's fine. All right, what do we got? Ah!
The suspense was real.
It was real. So what we can see on this is thing one still has the joke that we had in it before, because those variables are tied to that instance. That's why they're instance variables. Thing two has a different set of values for that. This is how we create objects that are all unique with different values inside of them, and yet they can share this same joke method, which is going to be called, but it's going to be called with those instance variables for each instance.
The other good thing about it is that they're accessible without getting passed, right? So in joke, you can get to it.
Yes. Yeah, that's another key aspect here. Is you notice, thank you, that's really good. You notice we didn't have to pass them into the joke. We didn't have to do anything special. And the reason we didn't is because these instance variables are part of this object, and any functions, any methods that are instance methods are able to access instance variables of the object inside of them without having to pass them in. That's the power of this object. This object is, does anyone remember I had a fancy word a few classes ago for how we can look at code in blocks and ignore other chunks of code? So this is known as encapsulation. What we've done is we've encapsulated these variables and these methods together so that we can think of them as one thing, as opposed to having to think of methods taking in arguments or something else. We're thinking of this whole thing as an object together, all encapsulated, and we don't have to try and deal with every bit of data separately. This is a very, very powerful concept in programming because it allows you to hide a lot of complexity so that you don't have to know about all the details going on under the covers. You only have to know some basics, and then somebody has implemented a lot of complexity behind that. Is there any questions on that? Not right now? All right. We only have a few minutes left. I don't think we have time to introduce any other new large concepts. I think this is enough to chew on for a day. We've just started introducing classes. I'll get you some homework out this afternoon. I may, in the homework, introduce one new concept and have us build on what we had before, and that may be how to read input from the command line, so that instead of right now, everything's either had to be encoded or in a file that we explicitly passed, like had defined in our file. I might add a bit of code so that you could do something like this. And then say we wanted to do this spell checking. So you could do spell check that RB and then maybe pass in the file name. That way you could write that same spell checking assignment that we were working on last time, but instead of having one book hard-coded in there that you could spell check against, you could pass in any book and get back out the words in it that didn't pass that spell checking. I'll probably introduce that concept in the homework just because it's useful to be able to understand how to pass stuff in, because that's really, we've built everything that we need then to have a very, very dynamic program that can change every time we run it.
I think another thing that might be good to know for instance variables is that they equal to nil versus a regular variable. So like if you do puts at whatever, it will not error out.
Oh, if I did. So let me, oh, I already exited out here.
That's something that threw me off when I first encountered it.
So what you're saying, and if I add this in, which I'm not going to save, but okay, that's a good point. Something I wouldn't have probably even checked against, but it acts a lot like the way that a hash works, in the sense that if you access a hash and a key that doesn't exist in your hash, by default, the value you get is nil. What he's saying is, we never defined this at blah, blah instance variable elsewhere, and as a result, it has nil here.
So it's pretty common that maybe you misspelled it or something, you get a nil, and instead of an error message, and you just misspelled it.
Right.
You never, or you didn't call it that at all. You're trying to call something.
Right.
If you call a method that doesn't exist, it will tell you this doesn't exist.
It doesn't exist.
Yeah.
Now I have a question for you though, and I don't know if you have the answer.
Okay.
I'm thinking that the reason it works that way is because of the way Ruby works, and since it didn't read a value there, it actually created the instance variable at blah blah, but it just doesn't assign it anything.
Yeah, I think so. I think like it will now exist.
So yeah, it exists.
Yeah.
So yeah, that's tricky because unless there's a way to check and see if it exists, you're never going to be able to know. You'll just always try and reference something and either, oh, now I have a nil instance variable, or I got the correct item. Yep.